Welcome to Physics A to Z. As a part of our bridge course, let us discuss about impulse concept today. Before going into the concept, just think about this. While watching a cricket match, you might observe this. A cricketer, while catching a ball, moves the hands in the direction of the ball, not directly just keeping the hands like this, but moves the hand in the direction of the ball. Why? We know it makes the catch efficient, but what is the physics behind this one? Similarly, what are the physics behind shock absorbers in a vehicle to reduce the impact on a speed breaker or on a pothole on a road? To reduce the impact, we use shock absorbers in a vehicle. How does it work? So behind all these things, there is a simple concept of mechanics, that is impulse. First of all, what is impulsive force and impulse? Impulsive force is nothing but a large force acting in a short interval of time. A large force acting for a short duration, short interval of time. Let us say you are hitting a ball with a bat. The force applied by the bat on the ball is large, but only for a fraction of a second. So that type of forces are called impact forces. When we fall down, the impact caused by the ground on us, that is an impulsive force. Okay, and what is impulse? Impulse is the impact caused by this impulsive force. So why does impulse cause? Impulse is caused due to change in the momentum. So let us write the equation for the impulse. Impulse, generally we indicate this with letter J. This is equal to the applied force, the impulsive force, multiplied with the time interval, delta t. So here F is the force applied and delta t is the time duration, how long the body is in contact. Okay, so this is the general equation for impulse. Now let us see some properties of this impulse. First of all, impulse is by vector quantity, because we know force is vector, right? And then impulse is obtained by multiplying force with time. Time is scalar, of course. So impulse, if you write in vector form, what can we write? Impulse is equal to force vector into the time interval. So this is the general equation. Then what will be the units for this? Let's write SI unit for impulse is Newton second, and observe this is same as linear momentum, and it is because we are multiplying force with time. So Newton into time second, right? So Newton second. You can also write this one as kg meter per second, but the generally used SI unit is Newton second. Then what is the dimensional formula? Dimensional formula is nothing but m L power 1 T power minus 1. Okay, then you are telling that it is a vector quantity. Then what is the direction of impulse? Let us find out. Direction of impulse is nothing but direction of the force itself. Why? Again, it is obtained from the force, multiplying force a vector with a scalar, that is time. So the direction remains same. So J, the impulse, is parallel to force vector. Okay, due to this equation. Now let us see some practical applications of this one. How is it helpful in our daily life? First thing, since impulse is equal to force into time, we can write force is equal to impulse by time interval. Now, what can we say from this? When the impulse is constant, if the impulse remain constant, then force is inversely proportional to the time interval. Let us take the example of catching the ball. When the ball falls on the hand, the momentum of the ball is transferred to the hand. We are experiencing a force, right? But what are we doing here? We are increasing the time interval. We are moving the hand in the direction of the ball. So the time of contact is increasing. As a result, force is decreasing. So time of contact increases and the force decreases. Hence, we experience less force. So it won't bounce off easily from the hand. The same thing apply for anything when you are using this. For example, the shock absorber in a vehicle. When the vehicle falls in a pothole or on a speed breaker, now the force is applied on the vehicle actually, but the impact, the change in momentum is same always, but the time of contact is increased due to the compression of the spring or some fluids used in the shock absorber. Due to this, the time of contact increases. As a result, the force is decreasing. So the people in the vehicle experience less force. So this is the magic behind the concept of impulse. Okay. And now, how do you find this impulse? Impulse, generally we gave one equation, that is impulse is force into time interval, and you can also write this one as change in momentum. Already we have discussed about momentum in the previous video, just go through that once. And change in momentum is nothing but the impulse. So now what can we say? The net force acting on the body, change in momentum, and impulse all are in the same direction. There is one more quantity in the same direction. What is it? Guess. Acceleration. Acceleration produced in the body due to this force. So all these things are in the same direction. Okay. Now let us try a question to find out impulse. Imagine there is a wall, a rigid wall. You throw a ball towards it, which is traveling with a speed v. Now it comes, hits the wall. After hitting the wall, it is going back along the same path. Assume like this. So it is hitting the wall and coming back in the same path. Okay, and again with the same speed it is going back. Now let us draw that. So hitting the wall and then coming back in the same direction and same speed. Now let us find out what is the change in momentum. In other words, what is the impulse here? How do you find change in momentum? Initially, let us say the momentum is P1. Finally, let us say the momentum is P2. Now the change in momentum gives you the impulse, and let's write the change in momentum equation. Change in momentum is nothing but final momentum minus initial momentum. And you know, when I talk about momentum, I mean linear momentum. Okay. So this is the equation. So what is the initial momentum here? Observe the ball here. It is coming toward the wall with the speed v. So initial momentum is mv. What is the final momentum? Mass into the velocity speed. It is v again. So initial mv, final mv. So change in momentum, mv minus mv, will it become 0? No. Direction is different. So what do we say? Let us assume a conventional direction. I am considering here the right side as positive and the left side as negative. You take the opposite, no problem. So now final momentum P2 is towards left, so that is minus mv in vector form minus initial momentum. Initial momentum is positive mv. So what is the total change in momentum? minus 2 mv. This is the change in momentum, and that also gives you the magnitude or the vector form of impulse, right? So this is how we find impulse. Learn the basics carefully, make the basics stronger, and everything else will become easy. All the best. Jai Hind.